Hello and welcome to today's video, where we will explore the amazing world of superconductors. What are superconductors, you may ask? Well, they are materials that have no electrical resistance and do not allow magnetic fields to penetrate them. This means that an electric current in a superconductor can flow forever without losing any energy, and a magnet can levitate above a superconductor without falling down. Sounds like magic, right? But it's actually science. Superconductors are not just theoretical concepts. They are real substances that have been discovered and studied by physicists for over a century. In fact, some of the most common metals, such as aluminium, lead and mercury, can become superconductors if they are cooled down to very low temperatures, close to absolute zero. But why do these materials behave so differently when they are cold? The answer lies in quantum mechanics, the branch of physics that deals with the smallest particles of matter and energy. When a metal is cooled below a certain critical temperature, the electrons in the metal form pairs called Cooper pairs. These pairs can move through the metal without being scattered by impurities or vibrations, unlike single electrons. This is why the electrical resistance drops to zero. But what about the magnetic field? Why does it get expelled from the superconductor? This is due to another quantum phenomenon called the Meissner effect. When a magnetic field is applied to a superconductor, it induces an electric current on the surface of the material. This current creates a magnetic field that opposes and cancels out the external field inside the superconductor. This is why a magnet can float above a superconductor, as if it were repelled by an invisible force. Superconductors have many fascinating properties and applications. For example, they can be used to make powerful electromagnets for MRI machines, maglev trains and particle accelerators. They can also be used to create superfast computers, quantum sensors and devices for renewable energy storage. However, there is one major challenge that limits the widespread use of superconductors: they require very low temperatures to work. Most superconductors have critical temperatures below 23 K, -250 degrees Celsius, which means they need expensive and complex cooling systems to maintain their state. This is why scientists have been searching for materials that can become superconductors at higher temperatures, preferably at room temperature or above. These are called high-temperature superconductors, and they are one of the holy grails of physics. The first high-temperature superconductor was discovered in 1986 by Georg Bednorz and Carl Muller, who won the Nobel Prize for their discovery. They found that a ceramic compound of copper oxide could become superconductive at 35 K, -238 degrees Celsius, which was much higher than any previous material. Since then, many other high-temperature superconductors have been found, with critical temperatures ranging from 50 K to 138 K, -223 degrees Celsius to -135 degrees Celsius. However, these materials are still far from being practical for everyday use. They are brittle, hard to shape and difficult to manufacture. They also need high pressures or chemical doping to achieve their optimal performance. Moreover, their mechanism of superconductivity is not fully understood by physicists, which makes it harder to design new and better materials. But there is hope. In 2020, a team of researchers reported the discovery of a room-temperature superconductor made from carbon, hydrogen and sulfur under pressures of around 270 gigapascals, 2.7 million times the atmospheric pressure. This material showed superconductivity at 287 K, 14 degrees Celsius, which is the highest temperature ever recorded for any material cubed. However, this experiment was done under extreme conditions that are not feasible for large-scale applications. The quest for room-temperature superconductivity continues, and it may take decades or even centuries before we find a material that can meet our expectations. But if we do succeed, we will unlock a new era of technological innovation and scientific discovery. Superconductors have the potential to revolutionize many fields of engineering, medicine, transportation and communication. They could also help us solve some of the biggest challenges facing humanity today, such as climate change and energy crisis. Thank you for watching this video. If you enjoyed it, please like and subscribe for more content like this. And don't forget to leave your comments and questions below. See you next time.